Airports use handheld metal detectors to safeguard flights. Treasure hunters use hobby metal detectors to find buried loot. Vastly different purposes, yet the technology behind them is identical. A principle called magnetic induction. It all hinges on tiny electrical currents creating magnetic fields. A tiny electrical current runs through a wire coil inside the detector, creating a magnetic field. When the detector passes over a metal object, the field is disturbed, producing a small voltage variation that triggers the alarm. To make the coil, they use copper wire that's coated with nylon insulation. They wind it around the two ends of a plastic bobbin a specific number of times. Polyester tape keeps it from unraveling. Security metal detectors need pure iron glued into the bobbin to increase the magnetic field strength the coil produces. Without it, the coil would have to be several times larger and wouldn't fit inside a handheld wand. The next step is to solder the coil leads to a circuit board. Then solder a vibrator motor to enable the detector to vibrate, as well as beep when it finds metal. The board contains a microprocessor, the detector's alarm, and other components that react to the signals coming from the coil. The coil and circuit board now go into the wand's plastic housing. A retaining clip holds the vibrator motor in place. They temporarily hook up power to the battery compartment and push a button on the circuit board. This calibrates the board to the coil. They install a sliding cap on the detector's on-off switch. Now they can close her up and stick on the manufacturer's label. The last step is to install the 9-volt battery. No metal detector leaves the factory before undergoing extensive quality control testing. Metal detectors for treasure hunting have larger coils, so they don't need iron inserts to boost the magnetic field. In fact, hobby detectors have 2 coils, one to transmit and one to receive. This configuration lets you set the device to detect only the types of metal you want to find. Like before, polyester tape prevents the wound wire from unraveling. The leads go into a device called a stripper, which bears the copper wire inside. A testing machine ensures the coil meets the engineering specifications. Next, they place a circuit board in the coil housing. A cable runs from this housing to the detector head, where components interpret the coil signals. After installing the coils, they solder the coil leads to the board. They immobilize everything with hot glue, then seal the components inside the housing with epoxy. Next, they install a circuit board inside the metal detector's control pad. They plug the cable coming from the coils into the board and power up. This calibrates the coils to the circuit board. Now they test the calibration with 3 different types of material the metal detector might find in the ground: iron, silver, and nickel. If everything works perfectly, assembly continues. They install a small speaker for the alarm. Then they attach the control pad to the head and apply the decals. They attach a handle and arm support, then a long stem. The cable from the coil winds upward around the stem and plugs into the detector head. Signals from the coil travel up the cable to the electronics in the head. A small computer analyzes these signals to determine whether the detector has found metal. If it has, the computer activates a circuit to set off the alarm and display a message. But the ground's by no means the limit. There are even metal detectors designed for scuba diving that are completely submersible.